In this video, we'll be looking at how to solve a compound inequality. And it's just one step more than solving an actual inequality. So let's look at an example. I would like us to solve in this video -2 is less than or equal to 3t minus 8, which is less than or equal to 10. Alright, so here is the only difference between this and a regular inequality. Instead of having two sides, we have three sides, and that's okay. So we're going to treat this exactly the same way we would treat a regular inequality, but whatever we do to one side, we have to do to all three sides. So in this case, we want to get our t alone, so we have to add 8 in order to get closer to having our t alone. But we can't do it to just one thing and not the others. We have to do it to all three parts of our inequality. So we're adding 8 to everything. So on the left, we get 6 is less than or equal to, in the middle, we have 3t, and on the right side, we have 18. All right, so now we're pretty close to having t alone. All we have to do now, since 3t is multiplied by, 3 is multiplied by t, we have to now divide by 3 everything. So whatever you do to one, you have to do to all. And on the left side, we end up getting that. We have a 2 over here. In the middle, the 3's cancel, and we get exactly what we wanted to get, which is a t, which is less than or equal to 6. And that should be your answer. But again, with inequalities, you want to make sure, you want to be comfortable with your answer, because you want to make sure that you're in the right region. So let's just pick a number between 2 and 6, an easy number to work with. So I'm going to try working with 5. Let's try 5 to check, because it's between 2 and 6, which is our answer. Alright, so I'm going to take 5 and I'm going to plug into our original. And our original inequality was that -2 is less than or equal to 3t minus 8, which is less than or equal to 10. And again, this is just a check. It's not required, but if you want to make sure you're getting the answer right, you want to check. So we're going to plug in 5 for t. And in the middle, we get, what is 15 minus 8? We get 7, which is in fact greater than -2 and also less than or equal to 10. So that's a great sign that our answer is in the right region. All right, so let's try another. All right, so this is an OR inequality, and it looks harder, but in fact it's not harder. It's just, it can be solved just like two inequalities, not a big deal. So what we want to do for this, because we have either 2x plus 3 is less than 5 or 4x minus 7 is greater than 9, we're not going to jump in and try to solve it all at once like we did for the AND inequality. We're just going to solve it separately. So let's do a little line down the middle here. So we know, we feel like we're doing two separate problems, even though it's the same problem. And we're going to subtract 3 from both sides, because we want that x alone, and we get that 2x is less than 2. And we're dividing both sides by 2. So again, we're working on getting that x alone, and we get that x is less than 1. And that's a part of our solution. Now that we've done the left side, we can go on to the right side and do the same thing to solve for x. We add 7 to both sides, and we get that 4x is greater than 16. And we now have to divide both sides by 4, again working on getting that x alone, and we get that x is greater than 4. And now, since this inequality at the very beginning was an OR inequality, because either 2x plus 3 was less than 5 or 4x was minus 7 was greater than 9. So either this or that. So in our answer, it's going to work the same way. Either x is less than 1 or x is greater than 4. That means if we try a number that is not either less than 1 or greater than 4, it should not work for either of these equations. So you're going to try and test this in the opposite way. You're going to try and test to see that a number in between these things don't work. So since x either has to be less than 1 or greater than 4 to work, I'm going to try, let's try 3. Or 2. 2 is even easier to work with. Let's try 2. So if you plug 2 into either of these inequalities at the beginning, it should not work. So test it out. We'll do that over in the corner here. Our first inequality, 2 times 2 plus 3 is less than 5. Is that true? Absolutely not. It doesn't work. And we didn't think it would, so that's great. But we have to test it again on the other inequality, which is 4 times 2 minus 7. Is that greater than 9? No, it's not. It doesn't work. So as we figured out here, it's true that x has to be either less than 1 or greater than 4. Anything in between does not work for either inequality. So we are correct.